Welcome back, 8th grade. We're in Eureka Module 1, Lesson 3, and we're going to be continuing our discussion on exponents by talking about exponents raised, the numbers in exponential form raised to a power, okay? And to start this lesson, I wanted to give you a little hypothetical here. So don't freak out about the story too much, but let's say I needed to get a whole bunch of fertilizer, right? So I go to the feed store and I can get a pallet. Let's say I buy a pallet of fertilizer that has 3 bags of fertilizer on it. On any given day, the feed store's only going to let me buy 4 pallets. So I would have 4 pallets of 3 added together. So I go to the feed store, and this is all they're going to let me buy on Monday. But I'm going to need a lot more. So I'm going to need to come in every day this week, essentially, and max out the maximum amount of fertilizer I can buy. So I go back on Tuesday, and I buy another 4 pallets with 3 bags each on it, and then I do that again on Wednesday, Thursday, and Friday, which would then look something like this right here. So I have week 1, week 2, week 3, day 1, day 2, day 3, 4, 5, up to Friday, and that is the total amount of fertilizer that I. Previously, we have talked about repeated addition, how repeated addition of the same number is the same as multiplication. So how could we rewrite 3 plus 3 plus 3 plus 3? How could we rewrite that? Excellent. We could rewrite it as 4 times 3, or 3 times 4, yeah? 4 threes, 4 times 3, or 3 times 4. By that logic, I can rewrite all of these 3 plus 3 plus 3 plus 3s as 4 times 3. So now I have an equation that looks something like this. It's kind of a little bit simpler, right? But look what's going on right here. I've got addition. I'm adding things. And what am I adding together? I'm repeatedly adding 4 times 3 together. So maybe there's a simpler way for me to write this expression. How do you think? How many times are we repeatedly adding 4 times 3? What's another way we could write that? Using the same logic we used right here to add, to change 3 plus 3 plus 3 into 4 times 3, well, we're repeatedly adding 4 times 3 5 times. So another way we could say that is 5 times 4 times 3. So I bought all the fertilizer I need. I'm on an FBI watch list. And now I've simplified my expression into 5 times 4 times 3. So the way we can see this is as I went 5 days that week. Each day I bought 4 pallets, each pallet having 3 bags of fertilizer on it. Using the commutative property, I can move these numbers around all I want. Since I'm multiplying 5 times 4 times 3, I can move these around any way I want. So if I wanted to think about it, I went 5 days a week, bought 4 pallets each day, and each pallet had 3 bags. So changing the brackets here didn't change anything. If I multiply all these together, it's the same as multiplying all these together like this. We get 5 times 4, which is 20, or in this case, 4 times 3, which is 12. 12 times 5, which is 60. And here we have 5 times 4, which is 20, times 3 is 12. And that will be true for any combination of ways you want to multiply these things. We multiply 3 times 5 first, we get 15, times 4, 60 again. So all of these are equal. Now let's just say instead of having to add 3 multiple times, let's just say we have a situation where we need to multiply 3 by itself multiple times. Let's say we needed to multiply 3 by itself 4 times. Well, we've already learned a shorthand for repeated multiplication. What is it? How can we rewrite 3 times 3 times 3 in exponential form, which is up here, exponential form? How do we write that? Well, it's 3 times itself 4 times. 3 is our base to the 4th power. So what if I have a situation like this? This is very similar to the addition problem we were looking at earlier, only this time instead of adding the 3s, we're multiplying the 3s together. So what if I find myself in a situation like this, where I need to multiply 3 times 3 times 3 times 3, 3 to the fourth power, times itself 1, 2, 3, 4, 5 times? Well, if we wanted to rewrite this group of 3 times 3 times 3, we can write it as 3 to the fourth again, right? So repeat that on down the line. We're going to write 3 to the fourth power for each of these. 3 to the fourth power times 3 to the fourth power times 3 to the fourth power. And again, we're multiplying these together now. Well, look at what we have ourselves here. We have repeated multiplication of a common term. 3 to the fourth power is the same as 3 to the fourth power and 3 to the fourth power. See what I'm saying? So these are common terms. They're all 3 to the fourth power, and we're multiplying them times themselves 1, 2, 3, 4, 5 times. So I want you to think about this. How could we rewrite this expression now, this shortened expression? Good effort. Good, very nice. I appreciate your work. So we have 3 to the fourth, and it's being multiplied times itself 5 times. It's a repeated multiplication, so we use exponents to denote that we're multiplying 3 to the fourth power times itself 5 times. So let's think about a way. Is there a way to shorten this expression right here? Is there a way to simplify it? What do you think? Okay, I see some of y'all went for 3 to the ninth power. Kind of like we did in the last lesson where we added the exponents, right? But no, this would be wrong. So now let's go back instead and think about the original problem here. So we had 3 times 3 times 3 times 3 times 20. We have 5 groups of 3 times 3 times 3, right? But remember that using the commutative property, when we're multiplying these terms together, we can rearrange these terms however we want. And since everything here is being multiplied together, for all intents and purposes, these parentheses don't exist. It's important to understand that this can only happen because everything is being multiplied. If there was any kind of addition or subtraction in here, then we could not ignore these parentheses. We would have to work with them. But since all of the terms are being multiplied together, the commutative property dictates that we move things around however we want, we can make the parentheses disappear. So now look what we have here. Look at this big old long statement right here, this big old long expression right here. What's actually happening? Very good. We're repeated multiplication. We have 3 times 3 times 3 times 3. How many times? So let's start by taking time. Let's actually count out how many 3s we have here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we're multiplying 3 times itself 20 times, so that's 3 to the 20th power. So now the question is, what happened from here, 3 to the 4th to the 5th power, and 3 to the 20th power? What happened? What did we do? Cool. Some of you noticed that if we multiply 4 and 5 together, we get 20. So when we're raising a power, when we're raising an exponent to another power, we multiply the exponent outside of the parentheses with the exponent on the inside of the parentheses. The base stays the same, so we maintain the 3, and we just multiply 4 times 5 to get us 20. So we say this as 3 to the 4th times 5th power, which equals 3 to the 20th. So that was kind of a long discussion to open up to this lesson that can be broken down pretty simply. This formula right here, we have x to the nth power, and we're raising this to the nth power, which equals x to the n times nth power, which is just like the example we looked at. We had 3 to the 4th power that we were multiplying by itself 5 times that we raised to the 5th power. And all we did was multiply the exponents together. We multiplied 4 times 5. And this is just another rule of exponents. Okay? When you're raising a power, like right here, x to the mth, to a power, then you just multiply the exponent on the outside with the exponent on the inside. And for exercises 1 through 4, that's really all we're doing. So for example, I'll take example 1 and let's do it together. So let's say we have 15 to the 3rd power and we raise that to the 9th power. How do we simplify this? Third step, give yourself to the top. Very good. We multiply the exponents on the inside times the exponent on the outside. We get 15 stays as our base, and we have 3 times 9 in our exponent, or 15 to the 27th power. Very good. Now, some of you who may have gone on to exercise 2 and may have seen this action right here. What are we doing with all these parentheses, right? What is happening right here? Okay, so the parentheses around the -2 is just to tell you that -2 is -2. It's all hanging out by itself. Then we have these parentheses right here, right? And that's containing to the 5th power. So really we're raising -2 to the 5th power, right? Now, since we have another set of parentheses right here and we have another power that we're raising it to it on the outside, we multiply the inside exponent with the outside exponent, and -2 stays our base, and we multiply the exponents 5 times 8 to get us -2 to the 40th power. 5 times 8 is 40, right? Now, again, in general, when you're doing negative numbers on their own, or really anywhere you want to put them in parentheses, that way the minus sign doesn't confuse anybody like it did last year. So, why don't you try exercises 3 and 4 if you need to. You can have a handy dandy calculator out. Do what you need to do with it. Again, guys, I appreciate your hard work. So for exercise 3, you should have come up with 3.4 to the 17th to the times 4 power, which when we simplify is 3.4 to the 68th power. And come take your calculator, 17 times 4, 68. Okay, in case you couldn't read my 68. So you should have got 3.4 to the 68th power. All right, so what about number 4? What did y'all come up with? I want to know, what did you find? All right, cool. I noticed that some of you know that it doesn't matter what the base is. S is a variable, so we don't know what it is, but it doesn't matter because we're not working these exponents out anyway. So S is our base, and we're multiplying the exponent 17 times 4, which we just did in the last one up here. So we know that S to the 68th power. Okay, right now, take about 2 minutes. Take 2 minutes and work exercise 5. Don't work exercise 6 for now. I'm going to come back to that at the beginning of the video. If you're in class with me, we're going to skip this one. We'll skip 6. You're working on exercise 5 right now. You go in 90 seconds, go. Guys, I really appreciate your hard work. As usual, thank you so much. The effort always is the most important thing. Okay, exercise 5. Sarah wrote 3 to the 5th power to raise to the 7th power equals 3 to the 12th power. Correct her mistake. So here they're already telling us that she's wrong. So we know that she made a mistake. Write an exponential equation using base 3 and exponents 5 and 7, 5, 7, and 12. That would make the answer clear. So first, we already know Sarah's wrong. They already told us Sarah was wrong. 3 to the 5th power raised to the 7th power would be 3 to the 5 times 7 power, which would equal 5 times 7 is 35, so 3 to the 35th power. But reading the the response part of the question here kind of gets a little confusing the way they frame it here. They want us to write an exponential equation using base 3. So our base is going to be 3 for all of these. And exponents of 5, 7, and 12. So we need to finagle all that to make it a true statement. Okay, so the base has to be 3 for each. Well, we know that 5 plus 7 is 12, so we have 3 to the 5th times 3 to the 7th equals 3 to the 12th. So here we have the exponential equation right here, base 3 for all of these. 1, 2, 3, base 3, exponents of 5, 7, and 12. Beautiful, and this makes sense. It's a correct answer. I just want to tell you that I really love the answer that you came up with. I thought that was a great answer. All right, so like I said, we're skipping 6. We're going to move down, and in your workbook, you should see it's right here. So for any numbers x and y, and positive integer n. So again, x, y, and n are just numbers. They're positive numbers. They're variables. They could be any number. And what this statement is saying here is that when you have an expression x times y, remember that when the variables or numbers are bumped right up against each other, it's just multiplication. So we're multiplying number x times number y, and then we're raising it to the nth power, some other number, that this is equal to x to the nth times y to the nth. And I'm going to go into further explanation as to why that is the case, but let's just come down here to exercise 7 and see how this will apply. This will be applied practically in the questions that we're going to be asked. Okay, so we can look at exercise 7 as an example. We have 11 times 4 equal 11 times 4 to the 9th power. Now look, you and I both know that we could work inside of these parentheses and we could just multiply 11 times 4 first. But that's not what they're trying to get us to do, okay? So don't forget about it. What they want us to do is take the exponent on the outside of the parentheses, the 9, they want us to take the exponent 9 on the outside of the parentheses and distribute. Remember from last year and last class, we used the distributive property to distribute the exponent on the outside into the exponents on the inside. So we're going to have 11 times 4. Now, we talked about this in lesson 2. 11 itself has an exponent, right? What is the exponent over the 11? Very good. The exponent is an implied 1. There's always an implied 1. So the same thing with 4. 4 is equal to 4 to the first power. There's always the implied exponent of 1. So we have the 1 over them naturally. And we're going to multiply 9 times both of our exponents. So we have 11 to the 1 times 9, which is anything times 1 is just that number. So 11 to the 9th times 4 to the 9th. And this is the answer that I would expect from y'all. But we both know that if we were to go back in time and we handle this like we would handle any other operation, we do what's inside the parentheses first. We can multiply 11 times 4 to get us 44. And that would just be 44 to the 9th power. So I feel like that's an even simpler version of this. And that's what I would be expecting. But for these exercises, what we're going to be doing is taking the exponent on the outside and multiplying it to the exponents on the inside. So let's just take 8 as an example. We'll take 8 and we will distribute the exponent on the outside of these parentheses into the exponents on the inside of the parentheses. And what do we do with the exponents on the outside and inside? What do we do with them? We are going to multiply. So in this case, 3 squared will multiply to 2 times 5. And I'm going to put a dot right here instead of an X for multiplication. I think that's cleaner. Anyway, we're going to multiply the 5 times the exponent over the 7. So we'll have 7 to the 4 times 5 power. And now we're going to simplify these even further because we can actually multiply 2 times 5 here and we'll get 3 to the 10th power times 7 to the 20th power. And I think this one was a better example of what we're trying to do right here, because you wouldn't want to actually bring out 3 to the 2nd power and 7 to the 4th power. So like when we were up over here, the 11 times 4, that was super easy to multiply, so we could have done that. But over here, 7 to the 4th power, that's not fun. I don't want to figure that out. So we'll leave it like this, and this will look good. And we're going to move forward to exercise 10. All right, because exercise 10 looks a little bit different, okay? So what we have here is 5x to the 7th power. And 5x is in parentheses here, which does make a difference, right? Because this does not equal 5x to the 7th power. What this is suggesting is just x is being multiplied 7 times. Here we're suggesting 5x is being multiplied by itself 7 times, so it's different. So in this example, we have 2 separate terms, right? What does it mean when the number is bumped up against the variable? Or you have 2 variables bumped up. What does it mean when they're right next to each other? What operations happen? Very good. There's multiplication happening, right? So what we have here is 5 times x. Remember, I'm using the dot for multiplication. 5 times x to the 7th power. So what we want to do again is distribute the 7 into the parentheses. We want to multiply the exponent on the outside with the exponents on the inside. So again, what's the exponent over 5? What's the exponent over 5 right here? It's an implied 1, right? But what about x? Does x have an implied exponent? Yes, it does. It also has x to the first. 5 is equal to 5 to the 1st power. X is equal to x to the 1st power. Even though we don't know what x is, whatever it is, it's equal to that number to the 1st power. All right, so we're going to rewrite this again. One more time, I'm going to write it as 5 to the 1st power times x to the 1st power, just so it can illustrate. So now we actually have numbers to be multiplying the exponents by, right? So we'll have 5 to the 1 times 7 times x to the 1 times 7, right? And then we're going to simplify this one more again. We'll have 5 to the 1 times 7 is just 7 times x to the 1 times 7 is 7. Now, technically you have a correct answer here, but I would want you to you can take the little multiplication sign out, right? Because again, we have 5 to the 7th, and we have x right next to it. This is an implied multiplication. So either one of these is fine, but this is kind of what I would expect you to finish that expression off as. All right, I'm going to rapid fire work out exercise 11, and then I want you to try exercises 9 and 12. If you want to go ahead and see if you can try exercise 11 right now on your own, you can pause the video and you try it on your own. Otherwise, I'm going to do a quick breakdown of how to do 11, and then I will give you some time. So for number 11, we're going to multiply 7, and this is how I'm going to do this without writing all that stuff in. I'm just going to multiply the 7 times the 2nd power, so that's going to get me y to the 2 times 7, which is 14. We're going to distribute it into the x. Again, this x has an implied exponent of 1, so it's 7 times 1, which is 7. So we have x to the 7th power, and then we'll distribute the 7 into this 5, which also has an implied exponent of 1, which will give us 5 to the 7th power. So final answer here would be 5 to the 7th, x to the 7th, y to the 14th power. We just multiplied the exponent on the outside with all the exponents on the inside. And remember, even if there's not an exponent apparently over the term, there's always an implied exponent, right? X equals x to the 1st, 5 equals 5 to the 1st, 2 equals 2 to the 1st. So now I want you to try exercises 9 and 12 on your own. If you haven't already done so, give yourself 2 minutes. Give yourself 90 seconds. Go. And this is what you should have come up with. So for exercise 9, you should have multiplied 5 times 2 to get you 3 to the 10th power, 5 times 4 to get you a to the 5 times 4, which is 20. Not where, I don't know where I got that number. But so 3 to the 10th, 5 times 2, 3 to the 10th power, and 5 times 4, 8 to the 20th power. I know my A's look like 9s. I'm trying my best. Please forgive me. We have 4 on the outside of the parentheses. In exercise 12, we have 4 on the outside of the parentheses, right here. And we'll distribute that and multiply it times each term's exponent. So we have 4 times 2, a to the 8th power. 4 times 1, remember, it's not nothing. There's a 1 right there. We have 4 times 1, which is b to the 4th. And 4 times 3, c to the 12th. Okay, guys, so I want to throw a curveball at you. I want to come up and look over here. Okay, so let's say we have a problem like this. 3 plus d. So we have 2 different terms being added together in parentheses to, let's just say, just the second power. Is there a way you could simplify that? Is there a way you could write that some other way? Okay, I see some of you are saying that we can distribute the 2 just like we did before, and we would have 3 to the second power plus d to the second power. And this would be incorrect. So notice, with all of the exercises that we've done so far, everything happening in here was multiplication. We were multiplying. This is all multiplication, right? So these rules do not work if you are adding terms on the inside of these parentheses. The whole game changes once you start having polynomials inside of these parentheses, right? So all of these are monomials. They all are products. They're all just being multiplied together. So it's a monomial. So these rules still apply, but not over here. So don't forget about that too much, but just know that this is not this. Okay, that's a bad. You messed up on that one. I actually had a very similar problem to this in the last lesson, and I did go over how to simplify this. So why don't you give it a try? See if you can do it. And I'm going to be right back, and I'm going to show you how to do it. All right, so what the exponent here is trying to tell us to do again is repeated multiplication of everything inside of this parenthesis. We're going to multiply this expression times itself 2 times. So that's what we have down here. Now from here, what you have to do, and again, don't spend too much time on this, but we're going to multiply, it's FOIL. We're going to multiply the first and then the end. So we'll have 3 times 3 is 9. 3 times d is 3d. Then we have d times 3 plus d3, which is the same as 3d, right? We can throw those things around, right? So plus 3d plus d times d, which is d squared. From here, we can simplify by adding these 2 expressions. Since they are common, they both are 3d. They're multiplying 3 times d both times. So whatever d is, it's going to be the same 3d or d3. So we can add these things. But how do we add them? What do we add? Well, we could say that we have 2 3d's, which is exactly what we're doing. Since we're adding these together, it's repeated addition of the same thing. So 2 times 3d. And what we do is we just multiply the numerals together. So we have 2 times 3d, which is 6d. Or you could just see it as 3d plus 3d. And you just add the numbers. If you have 3 of something and 3 more of that thing, then you have 6 of that thing. Okay? So then we have 6d plus d squared plus, we can't forget about this 9, okay? Don't forget about that too much. We don't do this a lot in this lesson, but I just wanted to show you that. So don't forget about it. You skipped it. That's great. Don't worry about that. I just want to let you guys know that anytime you feel like you've grasped a concept, like in the early part of a lesson, feel free to just move forward. So here on question 13, it is 13, right? 13. If you haven't done it already or you haven't challenged yourself, then you can do so. Otherwise, I just wanted to talk about this one because sometimes the way they phrase these questions is crazy. Let x and y's be numbers. Okay, no problem. They're numbers. Great. It doesn't matter what number they are. Except y can't be 0. That's what this means here. Y does not equal 0. Okay. Again, that's kind of irrelevant to what we're doing, but that's fine. Yeah, y can't be 0. And let n be a positive. So n is a number. Again, it's just some number. How is xy related to x to the nth and y to the nth? All right, so here's what's going on. So it might be easier. Let's make n equal, let's just make it equal 3, just for simplicity's sake. So we have x over y to the third power. Okay, so what is the exponent telling us to do? Very good, repeated multiplication. What are we going to repeatedly multiply? Very good. We're going to repeatedly multiply x over y. We're going to do it 3 times. Times x over y times x over y. All right. So from here, we're going to multiply. Remember, how do you multiply fractions? How do you multiply? Let's just say 1 over half times half. How do we multiply these things? Good, good, good. Okay, good. So we multiply the tops times the tops. 1 times 1. 1, and bottoms times bottoms. 2 times 2 is 4. So half of half is 1/4. Okay. Anyway, so when we're multiplying fractions, like we're doing over here, we're multiplying fractions. We're multiplying the tops times the tops and the bottoms times the bottoms. Well, look what we got right here. We're multiplying x times itself 1, 2, 3 times. Well, how can we write repeated multiplication of the same number? We keep its base and we add up all the exponents, right? So we have 1, 2, 3 x's, x to the third power. And same thing down here. We have 1, 2, 3 y's. We add up all of the exponents, y to the third. So there's that. Ladies and gentlemen, thank you for your attention. You can move down to the problem set, which you're gonna get off kind of easy, okay? So they want you to show and prove why this is this. No, look at what we did. You can do it. Just show. Just show me. Just show, okay? They're just telling you that this is true. Just protect the show. Why? Why is this? What happened from here to here? What did you do? How did they come up with these answers? Okay? Remember to check your rubric for how to respond to Eureka questions, and I'll see y'all in the next video.